We are already live. So this topic is a continuation of the previous one, which was the method of undetermined coefficients. We still have an equation with fixed coefficients, but now the right-hand side doesn't have a special form, and we want to use variation of parameters to solve that problem. So we still have an equation of the kind an derivative an minus 1 y n minus 1 plus a2 second derivative plus a1 first derivative plus a0y equals f of x, where a0 up to an are all constants. And the right-hand side, f of x, is not of a special kind like the one we had in the previous topic. So the first step in solving the problem using this method is exactly the same as in the other case. And we will specifically be talking about second order equations, which will be a2 y double prime, a1 y prime, a0 y equal f of x. The method will not change if you have an order n in general, right? And so issue is how to solve this. And in step 1, you want to write down the Euler equation, the homogeneous problem, and then solve it using the Euler equation. That's the homogeneous equation. The first step of the problem is solve this. And as of now, we are already professionals for this kind of problem. So we know that the solution of this problem is going to be capital Y of x equals C1 y1 of x plus C2 y2 of x plus and so on all the way up to Cn yn of x, where y1 up to yn is a fundamental set of solutions. We've proved that in the previous topics. Any such equation has this kind of solution with n functions that are fundamental, that form a fundamental set of solutions of the equation. So in your first step, you solve that using the methods that we use in the previous sections to solve the homogeneous problem. And then in the second step, you do variation of parameters. What we call variation of parameters here, it's a variation of these C1, C2, all the way up to Cn. In this solution, those are just constants, and we can call the other way of calling constants is parameters. Those are parameters of this solution. And it is a solution of the homogeneous problem. So we think using the ideas that we had for reduction of order, we think that if we make these coefficients functions and then we take their derivatives and plug into that equation, we might end up finding a solution of the original problem. So we do variation of parameters and we use y of x equal c1 of x. Now c1 becomes a c1 of x, a function of x. So you make it a function of x, c2 of x, y2 of x, and so on till cn of x, yn of x. So we make the constant function. That's what the method means. We vary these coefficients, we make them functions. And now we want to go ahead and take derivatives, and plug into the equation. Okay. Now, I'm not going to list here those derivatives and take all those derivatives because we don't need it. I'm just going to write down what happens when you plug in those derivatives and taking care of the variation that we have. The rule is that when you take those derivatives, the first derivative, when you take it, you make sure that the component that is in there that contains the first derivatives of c is 0. So you set that equal to 0. Then you take a second derivative, and that the other component that will contain the first derivatives of the constants, you again set it equal to 0 until you get the nth derivative, and you plug the remainder into the equation, and the last thing that you obtain will have a non-zero right-hand side, which is the right-hand side of the equation. And for that method to work, usually what you need to do to make sure you get the right answer is that where the problem starts, you get rid of the coefficient that is in front of the highest derivative. Make sure that coefficient is equal to 1, which is what we usually call in this class standardization, standardize, right? So you standardize, make sure that that first coefficient is equal to 1, which is obtained by putting g of x equals f of x over an as new right-hand side. And then you write what you get. So if I take the first derivative, I am going to get c1 prime y1 plus c2 prime y2 up to cn prime yn equals 0. After taking the first derivative, I do this. After taking the second derivative, I'm going to have c1 prime y1 prime c2 prime y2 prime cn prime yn prime equals 0. And I'm going to continue doing this until I hit the last equation. And in that last equation, I'm going to have c1 prime y1 n minus first derivative c2 prime y2 n minus first derivative Cn prime yn n minus first derivative. And this is going to be equal to that right-hand side, which is the original right-hand side divided by an. All equations that you are writing in between are equal 0 and are derivatives with derivatives of the function that you have all the way down to n minus 1. N minus 2 will be before that equals 0. Everything is equal to 0 except that first one. Now, if you remember what we call the Vronsky, we had W was y1, yn, y1 prime, yn prime, y n minus first derivative, yn n minus first derivative. This is how we define the Vronsky. So right there, you can see that these coefficients that are standing here is exactly that Vronsky that you have there. And the right-hand side is 0, 0, 0, 0, and then g of x. So in a compact form, for those who know algebra, we can write this. That this equation is nothing but W, the vector form, because W here is the matrix, but so W here I'm writing as the matrix that gives you the Vronsky, times C1 prime, Cn prime equals, and the right hand side is 0, 0, and then the last one, f of x over an. This is how you would write that in an algebra course, right? The Vronsky times this vector of c prime equals 0, and then f of x over an. Now notice that the length depends on the number of functions that you have. So for n equal 2, that is second order equation, you just have c1 prime y1 prime plus c2 prime y2 prime equals 0. Sorry, this is just y1 and y2, because the first equation takes the functions, and the second one, y1 prime plus c2 prime y2 prime equals f of x over a2. So this is the system that you will get when n is equal to 2. And you will just need to solve for c1 prime and c2 prime. So the second thing you need to do in your solution, is to write down this system. Write down and solve it. And that depends on what n is. For n equals 3, you're going to have 3 functions. So you're going to have c1 prime y1, c2 prime y2, c3 prime y3 equals 0, c1 prime y1 prime, c2 prime y2 prime, c3 prime y3 prime equals 0, and then c1 prime y1 second derivative, c2 prime y2 second derivative plus c3 prime y3 second derivative equals f of x over a3. And this is the system that you will get when n is equal to 3, when you're solving a third order equation with non-zero right-hand side f of x. And mainly in this course, these are the 2 types of equations that you're going to get. When you have third order, this is what you get. When you get second order, this is what you get. But in general, that's what it looks like, or in compact form, this. Any questions? That's just the step, right? First step, second step, you write that. Any questions before we continue? On step 3, what you do is solve for C1 prime, C2 prime, Cn prime. On step 4, integrate to get C1 of x, Cn of x. And then in step 5, return them into the formula of y of x, and that's how you will solve the problem. So again, first step, you write down the homogeneous problem, solve it. If you have the wrong solution to the homogeneous problem, you understand that your entire problem will be wrong, because these functions that you're using everywhere are the solutions of the homogeneous problem. So you need to get it right. Once you get that, you write down the system, second step. Then you solve the system. It's algebra, nothing differential equations in solving that. You solve the system algebraically. You get C1 prime, C2 prime, C3 prime. Now you integrate, that's calculus. You integrate each of them. Then you return the answers that you get into the formula of y of x that you wrote at the beginning of step 2, which is this. And that's it. And you're ready. And no matter what is that right-hand side, you apply this method, you're going to get the answer without knowing any special form. Questions? Let's see how it works on a specific problem. My guess is that this is 4.7 in your book. Section 4.7. Don't go look for other sections, because there are other sections that are not covered in the course and might have some information that trying to use might mislead. Now, let me get an example. So example 1, y double prime minus 4y prime plus 4y equals x plus 1 e to the 2x. So that's the equation that you have. And the question say you need to use variation of parameters. And also the problem is, this problem can actually also be solved using the method of undetermined coefficients. But yet the question will be, use variation of parameters to solve this problem. And you go step 1, okay, y double prime minus 4y prime plus 4y equals 0. It's already in standard form. Coefficient of second derivative is 0. You solve this. How? Euler equation, lambda squared minus 4 lambda plus 4 equals 0. When you solve this, you get lambda 1 equal lambda 2 equals 2 using your quadratic equation. And so the capital Y of x is C1 e to the 2x plus C2 x e to the 2x. So that's what you do. And therefore, this here is y1, and that is y2 that is used in the method of variation of parameters. If you miss that, and the whole rest of the problem is useless. You understand why it is paramount to be able to solve this correctly, get the proper lambda 1, lambda 2, and know the proper formula for the case that you get. Then you go to your second step. You say, I want now variation of parameters. I want y of x equals c1 of x e to the 2x plus c2 of x times x e to the 2x. So I want this. And so my system is c1 prime of x e to the 2x, c2 prime of x e to the 2x equals 0. And the second equation is c1 prime of x, and then derivative of e to the 2x, which is 2, so 2 comes here, e to the 2x, plus derivative of this, c2 prime of x, derivative of xe to the 2x. So it's going to be 2x plus 1 e to the 2x equals the right-hand side of the equation. And the right-hand side of this equation is x plus 1 e to the 2x. And so this is the system that you need to use to solve the problem. There's two ways of solving this problem. You can take the first equation, solve for C1, plug in here to do and solve, but you can also use the Kramer's method to solve it. So C1 prime of x is W1 over W, and C2 prime of x is W2 over W, where W is the Wronskian, which is listed in the system e to the 2x, x e to the 2x, and their derivatives. E to the 2x is 2 e to the 2x. You need to have the correct derivatives, otherwise everything else you're doing is useless. So that's the Wronskian, and we compute that Wronskian. So here is 1 plus 2x times e to 2x e to 2x e to the 4x minus 2x e to the 4x, and 2x e to the 4x cancel. So we get that the Wronskian is e to the 4x. That's W. And W1 is obtained by replacing in W the first column by the right-hand side of the equation, 0, x plus 1. So that is 0 x plus 1 e to the 2x, and then keep the other one, which in general can be given as negative f of x y2 divided by w, sorry, it's a negative f of x times y2, okay? Because here is the f of x that you have, and that's the y2. So that's why w1 also given as negative f of x y2 over w. And your f of x is given, that's x plus 1 e to the 2x times y2, which is x e to the 2x, divided with the minus sign for this, divided by w, and w is e to the 4x. Also, w2, you replace the second column by the right-hand side of the equation 0, 1 plus x, and it gives you that w is f of x, y1. That's what you will get. And so this is f of x, y1 over w. Notice the difference between the two. The first one comes with a minus, and there's no minus for the second one. And that f of x is x plus 1 e to the 2x times y1, and y1 is e to the 2x over w, which is e to the 4x. So that's how you would apply these two formulas. And that leads you to c1 prime of x equals negative x squared plus x, which is x plus 1 times x, e to the 2x times e to the 2x, it's e to the 4x over e to the 4x, they cancel. c2 prime of x, same here, e to the 2x times e to the 2x, e to the 4x over e to the 4x, they cancel. And c2 prime is x plus 1. So that's how you end with step 2. You got c1 prime of x, you got c2 prime of x, and in your third step, you integrate. And so here, you're gonna get c of x is integral of negative x squared plus x dx. That's negative x cubed over 3 minus x squared over 2 plus a constant. That's c1. And then c2 of x is therefore integral of x plus 1 dx, which is x squared over 2 plus x plus a constant c2. And that's how you get down to step 4 to the word was return them to y of x equals c1 of x, y1 of x, plus c2 of x, y2 of x. What do you return there? You return the answers that you got on the previous step. So that gives you y of x equals minus x cubed over 3 minus x squared over 2 plus c1 times e to the 2x plus x squared over 2 plus x plus c2 times y2, which is x e to the 2x. That's it. And this is the final general solution of that problem with non-zero right-hand side. Any questions? Does this make sense?
I think
Yeah,
it
that
makes
makes
sense.
sense.
Thank you. So that's technically what it is. That's how it works. And here we looked at it for a second order problem. Now let's do it for a third order problem when you have three functions. Say example 2. And say we take a problem of order higher than 2. So 2y cubed minus 6y double prime equals x squared. That's an example. So here it's order 3. So n equals 3. So you're going to have three functions. First thing first, standardize that problem. So that gives you, make sure the coefficient of the highest one is 1. So it's going to be x squared over 2. That's where we start. So we standardize the problem. Then we write down the homogeneous problem that we need to solve. Start step 0, step 1. So that gives you lambda cubed minus 3 lambda squared equals 0. So lambda 1 equal lambda 2 equals 0. Lambda 3 equals 3. That's what comes out of there. And so you write down the capital X, Y of X. It's going to be C1, C2, C3. Lambda equals 0 twice. So that is C1 e to the 0 plus C2x e to the 0 plus C3 e to the 3x. So this is what the solution of the homogeneous problem is. And so y1 is 1, y2 is x, and y3 is e to the 3x. That's it. y1 is 1, y2 is x, y3 is e to the 3x. And then in step 2, you want to do variation of parameters. Little y of x is c1 of x plus c2 of x times x plus c3 of x times e to the 3x. And your system of equation, you need to write that system down. I need to see it for you to get full credit. So that system is going to be C1 prime times Y1, which is 1, C2 prime times Y2, which is X, C3 prime times Y3, which is e to the 3X, equals 0. Second equation, C1 prime times Y1 prime derivative, that's 0, plus C2 prime Y1 derivative of X is 1, plus C3 prime times derivative of e to the 3x, that's 3 e to the 3x, equals 0. And the third equation is going to be the thing that is equal to the right-hand side of the equation. And so get C1 prime times derivative of 0, it's 0, plus C2 prime times derivative of 1, it's 0, plus C3 prime times the derivative of 3 e to the 3x is 9 e to the 3x, equal, and the third equation is equal to the right-hand side, which is x squared over 2. So that's the system that you have. And right away, when you do that, you can write W. That's 1x e to the 3x, 0, 1, 3 e to the 3x, 0, 0, 9 e to the 3x. So when you compute this, you get 9 e to the 3x. Why is that? Because here, when you break it down, it's just 1 times this one, which is just 1 times 9 e to the 3x. You have only zeros below the diagonal. When you have zeros everywhere below the diagonal, the Wronskian is equal to the product of the functions that you have on that times 1 times 9 e to the 3x, which is 9 e to the 3x. So you got your W, and then from there, you can find W1. So W1, let's do that here, is, I said for W1, replace the first column by the right-hand side of the equation, that's 0, 0, x squared over 2. And keep the rest as is, x, 1, 0, e to the 3x, 3 e to the 3x, 9 e to the 3x. When you compute this, you can split with respect to the first column, that gives you x squared over 2, and the minor is going to be x, 1, e to the 3x, 3 e to the 3x, and the other minors are going to be multiplied by 0, 0, 0, so we don't need to write them down. And so this is equal to x squared over 2, and you multiply this, that is times 3x minus 1 e to the 3x. That's what you get as W1. Then you get W2, replacing the second column by the right-hand side. The first remains same, 1, 0, 0. Second is replaced by the right-hand side, that's 0, 0, x squared over 2. And the third remains e to the 3x, 3 e to the 3x, 9 e to the 3x. Again, if we compute this thing by the first column, we remain with 1 times the minor is 0, 3 e to the 3x, x squared over 2, 9 e to the 3x. And this is equal to minus 3 halves x squared e to the 3x. So that's W2. And then you find W3. Replacing the third column by the right-hand side, and that's the third column. All other columns remain same, so that's 1, 0, 0, x 1, 0, 0, 0, x squared over 2. And because all numbers below the diagonal are zeros, this w equal the product of the numbers that you have there. So that's 1 times 1 times x squared over 2, which is x squared over 2. So we got all the w's. We got all the w's, and we can now find the functions. C1 prime of x is w1 over w, and that is 3x cubed minus x squared over 2 divided by 9. So 1, 9. And e to the 3x cancels with this e to the 3x. So that is 1/6 x cubed minus 1/18 x squared. C2 prime of x is w2 over w. So this is w2 over w. It's going to be negative 1/6 x squared. And the e to the 3x cancels. C3 prime of x, w3 over w. And this is x squared over 2 divided by 9. So x squared over 18 e to minus 3x. So these are all the derivatives. You integrate this, you get c1 of x equals integral of this is going to x to the 4th, 1/24 x to the 4th minus, and cube 18 times 3. That's 54, right? Are we good? The integral of x squared.
Yes.
So the integral of x squared is x cubed over 3. 3 times 18. I was saying it's 54. X cubed. And then the constant of integration, c1. This one, you integrate as well. We get c2 of x equals integral of negative 1/6 x squared. That's negative 1/18 x cubed plus c2. And the last one is where you have a little more work. So c3 of x is integral of x squared over 18 e to minus 3x dx. And this you need to integrate by parts 3 times or 2 times. So integrate this by parts. I'll give you a few minutes to do that, please. Do that integration by parts and tell me what you get. Want to try it, Jimmy? William?
I am very stuck right now.
Cooper?
I'm sorry, I'm in kind of the same boat.
I think I may have it.
Okay. That the first step.
Okay. Are you talking about the integration still?
Yeah.
Okay. Is it negative 1 over 54 x squared e to the negative x?
You said x squared e to negative 3x.
And then, yes, and then minus 1 over 81 x
Oh, after
e
that,
to the negative.
I understand. Let's go step by step on your integration by parts. This is the first part. What comes next in the integral before you give me the answer next? We are doing integration by parts. The first step by parts. You get this, and then what is in there? This is what we call integration by parts.
I don't think I wrote that down. I think I just skipped over just a second.
Mm-hmm. In your parts, what are you taking as u and what are you taking as dv? You want to try, Mercy?
I can. I think I have it, but I'm not 100% confident. Can I do it step by step like you were about to do with you, just to make sure I did it right? Because I was using my dv as e to the negative 3x,
That's
and
correct.
then v would be negative 1/3 e to the negative 3x.
Yeah.
U would be the x value, and then you take the derivative of it each time.
So what do you get on the first step?
Negative 1 over 54. I had it still broken up. So I had x squared over 18 times negative 1/3 e to the negative 3x
Which is exactly that.
minus the integral of negative 1/3 e. Huh?
I said, which is exactly what she
What
said.
was that? Uh-huh. So
Your minus, I'm combining it with this other minus. So what's there again?
and so inside it should be v du. So it should be 1/3 e to the negative 3x times x over 9, because the u value was x squared over 18. So the derivative of that would be x over 9.
That's
So
one.
yeah.
Then x e to negative 3x. That's what you said, right?
Yes, just I said it way longer than that. I'm sorry about that.
No, it's good. So we are going through it step by step, which is okay. So that's what your first step gives you. And then you do it again by parts.
Isn't u x squared over 18? Sorry, I was just making sure.
Yeah, you're right. You're absolutely right. I was reading next to it here. So I'm seeing this thing. And there actually was no negative there. Right? I read the wrong guy from a different equation completely. Now, what happens with these parts? This is also by parts.
Wouldn't it just be x over 27 times negative 1/3 e to the negative 3x minus the integral of negative 1/3 e to the negative 3x times 1 over 27? Which I need to simplify my fractions that is having, and I'm sorry about that.
Then minus, and what is in there?
Inside the integral would be negative 1/3 e to the negative 3x times 1 over 27. So positive.
Then the number here would be 1 over
81.
inside.
Mm-hmm.
Because that is 27 and then 130, yep.
20.
As it does to 127, then 1/3 from here, right?
That's what.
And then e to the.
And then times e to the negative 3x.
And now this is a simple integral. You integrate this as well. So you get negative 1/54 x squared e to the minus 3x minus 181 x e to the negative 3x, and then here minus 1 over 81 times 3. How much is that?
$243, right?
That's what I'm thinking. And then e to minus 3x plus the constant of integration. That's it. So you got C1, C2, and C3 of x. Now that you got all of them, you take them back into the formula to get y of x. That's it. Last step. That was step 3 here. And on step 4 here, return to y of x equals c1 of x, y1 is c2 of x, y2 plus c3 of x, y3. That's it. Questions? So this is basically how the method works. Any questions, please? Okay. No questions. Let me give you another one that you do by yourself now with the remaining time. I give you a second order, not a third order. Exercise. Say y double prime plus y equals sine x. That's it. Just as simple as this. Solve using variation of parameters. We know how to solve this using the method of undetermined coefficients. And sometimes actually on your test, I might give you the same problems for the two methods because I'm actually not interested in the final answer, but in seeing how you apply the method. So I can give you this same problem twice. Say, use the method of undetermined coefficients to solve, and then I say, use variation of parameters to solve that same problem.
Dr. Long,
Yes?
isn't on the right side, isn't that n equals 0?
That's sine x.
So is that a first order equation? I'm sorry, that's a dumb question.
Second derivative plus y.
Okay, never mind. It's just, okay, thank you.
Welcome. One of my school teachers used to say, there is never a dumb question, there are dumb answers. If you ask and I can't tell you what helps you, then I'm dumb. All right, anyone with something that we can chew?
I got the first step down.
Okay, go ahead.
So the Euler equation is going to be lambda 2 equals -1, and then that's going to give you lambda 1 and 2 equals plus minus I.
Correct. And so y of x.
Yeah, and so the capital Y of x equals C1 cosine of x plus C2 sine of x.
That's right. That's the beginning. So you got that one correct. That's a good beginning. Otherwise, everything else is going to be useless. So when you do that, you have y1 and y2 right there. Step 2, write down the equations system. The system of equations. What is
And
it?
I got C1 prime cosine x plus C2 prime sine x 0. And then C1 prime negative sine x plus C2 prime cosine x. And that's going to equal sine x.
Correct. That's it. And now you can go ahead and find your W's. So what's the W of the whole thing?
Cosine squared x minus sine squared x. I know that's triggered.
Be careful, you might have a mistake if you fly through it. Just write them down first. What are the functions?
Cosine x, negative sine x,
Correct.
sine x, and cosine x.
And now check carefully what's going to happen.
Cosine squared x plus sine squared x.
And how much is this?
Is it arctangent?
No. Sine square plus cosine square. Trick, identity.
1.
1. That's it. Now, W1. For a 2 by 2, we know that W1 is negative f of x times y1. And sorry, negative f of x times y2, right? Over w. And not w1, but c1 prime, sorry. All right. So what is c1 prime? It's f of x.
Sine x or negative sine x.
No, negative is already here. So f of x is sine x, and then y2 is
Sine x.
sine x. So if you follow this system, it's just going to be straightforward like this. W
Is 1.
1. That's it. So you got negative sine square x. Now c2 prime is f of x y1 over w. F of x again, sine x, y1
Cosine x.
sine x over 1. So that's sine x cosine x. That's it. And now you go to step 4 to integrate. C1 of x is integral of negative sine square x dx. And now this is the place where you need some of these identities somehow. Whenever you have integral of the square of sine, you need to remember this. You cannot integrate it unless you use the half angle formula, which states that when it's cosine,
Hey,
for example, what is that?
how you doing? Love you.
It says cosine square x is equal to 1 plus cosine of 2x over 2. And sine square x is 1 minus cosine 2x over 2. So these formula are from trigonometry. And you can check that cosine square plus sine square equal 1. And sine x cosine x is nothing but sine 2x over 2. So these formulas are pretty handy when you're solving problems like this and you encounter sine squares, cosine square. So in this integral, if I don't know this, I'm done. If I know, I'm going to write down that negative sine square x here is just going to be cosine of 2x minus 1 over 2 dx, and then easily I compute the integral. Otherwise, there's just nothing I can do. Integral of cosine 2x, that's we're going to be 1/4 sine 2x, and then minus x over 2 plus c1. And then c2 of x is integral of this one, which is sine x cosine x dx. I can use this formula also to bring it to sine 2x before integrating, but I just leave it like that. I know that this is 1/2 sine square x, because the integral of sine x times cosine x, this is u sub, the derivative of sine x is cosine x, so this is the derivative of 1/2 sine square x by u substitution. Does that make sense?
Yes.
All right, so this is what you get. You get C1 of X, you get C2 of X, then you return the whole thing. Y of X equals C1 of X. That's 1/4 sine 2x minus x over 2 plus C1 times cosine x plus 1/2 sine squared x plus C2 sine x. That's it. That's the general solution to the problem. Guys, have any questions? Well, if not, then that's it for me today.